Hello guys, welcome back to my channel. Now this is part 2 of the part 1 video that I did on the symmetry of roots of cubic equation. In part 1 we did all the derivations, so in part 2 we're just showing you some possible questions that could be asked. Now bear in mind that we had established a connection between the roots of the equation and the coefficients of the equation. So the first thing I want to do here is to simply just write down the coefficients. So here we're going to have that a is equal to 4, b is equal to -3, C is equal to 7, and D is equal to -2. So we can start by making the connection that we had established in the previous video. And bear in mind that we had said that the sum of the roots, which is alpha plus beta plus gamma, is equal to -b over a. Alpha beta plus alpha gamma plus beta gamma is equal to c over a. And alpha beta gamma is equal to -d over a. All right, so the sum of the roots here, b is -3. So if we negate -3, it's going to be a positive 3. And we know that a is 4. So pairwise here, we say is equal to c over a, and c is 7. So I'm going to have 7 over a, which is 4 again. And alpha, beta, gamma, which is a product of the roots, is equal to -d. D is -2. So when I negate that, I'm going to get positive 2 over 4, which you could also break down to a half. Now that we have the most three critical things, we can practically ask you anything. So we know what the sum of the roots is. We know what the sum of the product of the roots is pairwise, and we know what the product of the roots is. So this is part A. Find 1 over alpha plus 1 over beta plus 1 over gamma. Once again, upon assessing this, realize that it is a fraction, all right? And I can't make a substitution unless I'm seeing one of these three critical components. So since it's a fraction, I can probably go ahead and break it down. We can find the LCM, and my LCM here is going to be alpha, beta, gamma. Now alpha into alpha, beta, gamma is going to give me beta, gamma. And you start seeing a pattern once you have found the first one, because beta into this now is now going to give me alpha, gamma, and gamma into it is going to give me alpha, beta. All right, so we have the sum of the product of the roots pairwise being divided by the product of the roots, and we know what the values for these are. So this is going to give me 7 over 4 divided by the product of the roots, which is a half. All right, we can simply break this down. So I'm going to end up with 7 over 2. Here's the next possible question, question B. So I'm supposed to find all this. Alpha square beta gamma plus alpha beta square gamma plus alpha beta gamma square. Once again, it is dependent on your algebraic skills to be able to pick up when something is a fraction, when something is common, when I can apply the laws of indices and so on. Now, by just looking at this term right here, I would notice that all three terms have in alpha, beta, and gamma. All right. And what do I do when something is common? I factorize it. So we could factor out an alpha, beta, gamma. Now, what happens when I factor out an alpha, beta, gamma? When I factor that out, I'm going to have alpha plus beta plus gamma left. Now, do we know what these are? Yes, I know what the product of the roots is. It is equal to a half. And I know what the sum of the roots is. It is equal to 3 over 4. So when I break this down, I am going to end up with 3 over 8. Now here's our next scenario where we want to find alpha square plus beta square plus gamma square. And we dealt with this in the previous video when we had the symmetry of roots of quadratic equations. All right. So we're just going to move right into it. So we're going to consider alpha plus beta plus gamma all squared. And just like in the previous video, we said that we can use a shortcut to expand this. So this is going to be equal to or equivalent to alpha square plus beta square plus gamma square plus 2 alpha beta plus 2 alpha gamma plus 2 beta gamma. All right. In the previous video, we had done a video to show you how we expanded this. So we're typically using the shortcut here to expand it. You can go ahead and multiply the bracket by itself if you want to see how this is done. Now bear in mind what I want. I want alpha square plus beta square plus gamma square. So I'm going to have to transpose this system. So we can say that alpha plus beta plus gamma all squared minus, And notice if I bring over all of those three terms, they're going to be negative. So I can factor out a negative 2. I'm going to have alpha beta plus alpha gamma plus beta gamma is equal to alpha square plus beta square plus gamma square. So I could write this as alpha square plus beta square plus gamma square equal alpha plus beta plus gamma all squared minus 2 times alpha beta plus alpha gamma plus beta gamma. And we know what all these are. So let's go back up here. So we had found these already. So alpha plus beta plus gamma was 3 over 4. The pairwise was 7 over 4. And the product was a half. So this is going to give me 3 over 4 all squared minus 2 times 7 over 4. And all of this is we're going to break down to give me negative 47 all over 16. Now here's a bit of a challenge question. You can go ahead, pause the video, attempt the question, and come back and look at the solution. But once again, this scenario, we have given you some fractions, so we're adding the fractions, so we can go right ahead and find the LCM. My LCM in this scenario would be alpha, beta, gamma, if I'm keeping it alphabetical order. So I'm going to have beta into alpha, beta, gamma, which is going to give me alpha, gamma. But note my numerator is alpha, gamma, so I'm going to end up with alpha, gamma, all squared. Now gamma into alpha, beta, gamma is going to give me alpha, beta. But my numerator again is alpha, beta, so I'm going to have alpha, beta, all squared. And this thing always happens in a certain pattern. So almost sure that I can predict what the next term is going to be. Now alpha into alpha, beta, gamma is beta, gamma, and my numerator is beta, gamma. So I'm going to have a beta, gamma, all squared. The numerator almost seems familiar. All right, recall that when we had alpha squared plus beta squared plus gamma squared, this was equal to alpha plus beta plus gamma all squared minus 2 alpha beta plus alpha gamma plus beta gamma. So I could actually use this comparison to work out my numerator, right? Let me put them side by side. So I have alpha, and let me write it in order. So I have alpha beta squared plus alpha gamma squared plus beta gamma squared. Now, looking at this, we realize that in the place of alpha, we now have alpha beta. In the place of beta, we have alpha gamma. And in the place of gamma, we have beta gamma. So what it means is that on the right, I'm also going to be making those replacements. So this is what it's going to look like. Replacing alpha with alpha beta, I'm going to have alpha beta. Replacing beta with alpha gamma, I'm going to have alpha gamma plus beta gamma all squared minus 2. I'm going to have to apply a similar approach in this bracket. So if I replace alpha with alpha beta and I replace beta with alpha gamma, then what I'm going to end up with is alpha squared beta gamma. And we can almost write down the other terms because it's going to take on a similar pattern. If I replace alpha with alpha beta and gamma with alpha gamma, then, well, sorry, with beta gamma, what am I going to get? I'm going to end up with alpha beta square gamma. So we can actually just write down the next term, which is alpha beta gamma squared. This could take a bit more modification. So I could go ahead and say alpha beta plus alpha gamma plus beta gamma all squared. And then here you notice that alpha beta gamma is common for all three terms in the second bracket. So I could say minus 2 alpha beta gamma, which is going to leave me with alpha plus beta plus gamma. All right. Now we can go ahead now and put back everything together. So this expression is actually going to become alpha beta plus alpha gamma plus beta gamma all squared minus 2 alpha beta gamma times alpha plus beta plus gamma all over alpha beta gamma. And we know the values of these from the previous question. So we're just going to plug them in. So this, bear in mind that the sum of the product of the roots pairwise was actually equal to 7 over 4. So I'm going to have 7 over 4 all squared minus 2 times a half, which is the product of the roots, times 3/4, which was the sum of the roots, all over the product of the roots, which is a half. Now, when I break down all this, you can actually use a calculator, plug in everything. It's going to break down to give you 37 over 8.